Hello there, and welcome to the Sleepy Science Channel. Tonight, we'll be discovering some of the most remarkable predators on Earth. They rule the wild with strength, intelligence, and quiet grace. This is the world of the big cats. Not just the lions and tigers you're familiar with, but a stunning array of creatures from around the globe. These animals are more than symbols of power. They're finely tuned results of evolution, shaped over millions of years to survive in some of the planet's most challenging environments. From the icy cliffs of the Himalayas to the open savannas of Africa, big cats have adapted in extraordinary ways, each species revealing a different side of what it means to be both hunter and guardian of the natural world. We'll explore how they think, communicate, and thrive, and what their presence tells us about the health of entire ecosystems. It's a story of balance, adaptation, and mystery, told through the quiet rhythm of science and nature. If you enjoy these quiet journeys, I invite you to like, subscribe, or share a thought below. It helps others find their way here too, one sleepy soul at a time. For now, just breathe. Let your eyes grow heavy, and let the wild cradle your thoughts, calm, steady, and free. Let's begin. The roar of a lion can travel across miles of open savanna. A lion's roar isn't just loud, it's an acoustic force designed for distance. At full power, the sound can carry for more than 5 miles across open land. The roar begins deep in the chest, where powerful muscles push air through a flexible larynx, unlike that of any other cat. The folds vibrate slowly, producing a deep, resonant call that travels far through the air. Lions use it to announce territory, locate members of their pride, and warn rivals to stay away. When several lions roar together, the sound waves overlap, creating an effect that feels like thunder rolling across the plains. Even elephants and buffalo react to it. The sheer physicality of the roar, that deep vibration you can feel in your chest, is a reminder that sound itself can be a weapon, a language, and a declaration of presence all at once. Tigers each wear a unique pattern of stripes, like a fingerprint written in fur. Every tiger's stripe pattern is singular. No two have ever been found to match. These stripes aren't random decoration, they're functional camouflage, breaking up the tiger's shape amid dappled light and tall grass. Even the skin underneath carries the same pattern, as if nature painted them from the inside out. The arrangement of black lines and orange fur helps the tiger disappear in plain sight, allowing it to stalk silently through its world. Scientists use these patterns to identify individuals in the wild, building databases that track movements and population changes. The evolutionary artistry is astonishing. Each tiger's coat is an unrepeatable signature, passed down through generations. In infrared light, the pattern is still visible, hinting that these designs work across multiple visual spectrums. To the human eye, the tiger's beauty is mesmerizing. To its prey, that beauty is invisible until it's far too late. Leopards can carry prey heavier than themselves up into the trees. The leopard's strength borders on unreal. These cats often haul entire antelope, sometimes weighing twice their own body mass, up vertical tree trunks to store their kills. This behavior isn't just athletic, it's strategic. By lifting food high into the branches, leopards protect their meal from scavengers like hyenas and lions. Their muscular shoulders and back give them the leverage to drag weight that would exhaust almost any other predator. Once perched above, the leopard drapes the carcass over a branch like a larder, returning for days to feed. Scientists believe this remarkable behavior evolved to help solitary leopards survive among stronger competitors. Watching one ascend, a blur of spotted muscle and grace, feels like watching gravity itself lose its grip. Its power hidden within elegance, nature's quiet reminder that strength doesn't always announce itself with noise. Sometimes it moves silently through the trees. Jaguars bite through skulls with jaws strong enough to pierce bone. Of all the big cats, the jaguar possesses the most formidable bite relative to its size. Its jaw muscles are arranged for crushing rather than slashing, allowing it to pierce even the thick skulls of caimans and turtles. Unlike lions or tigers, which usually suffocate their prey, jaguars often kill with a single bite to the brain. Their teeth are built for it, large, conical, and deeply rooted. The bite force is estimated to be strong enough to punch clean through bone, equivalent to several thousand pounds of pressure per square inch. In the dense rainforests of Central and South America, this method is supremely efficient. The jaguar's hunting style is an ancient echo of a time when strength and precision meant survival. Its power is not loud or showy. It's absolute, controlled, and perfectly tuned to its world. One silent strike, and the forest holds its breath. Snow leopards are ghost-like wanderers of high mountain air. Hidden among the peaks of Central Asia lives the snow leopard, an animal so elusive that locals call it the ghost of the mountains. It inhabits altitudes higher than most birds of prey, thriving where the air is thin and the landscape unyielding. Its pale fur blends with rock and snow, patterned with soft grey rosettes that vanish into the light. Everything about the snow leopard is built for cold and silence. Wide paws spread its weight across snow, dense fur insulates against freezing winds, and a long, thick tail wraps around the body like a blanket during gaul. Rest. Its vocal cords lack the structure needed for a true roar, so instead it communicates with low growls and a gentle, rumbling chuff. For centuries, its presence was myth, a flicker seen at the edge of a storm. Even now, to see one in the wild feels like glimpsing a dream. Cheetahs trade power for speed, built for breathtaking acceleration. The cheetah is evolution's sprinting masterpiece. Everything in its design serves one purpose: speed. Lightweight bones reduce mass, long, flexible spines act like springs, enlarged nostrils flood the lungs with oxygen. In a burst, it can accelerate from stillness to more than 60 miles an hour in just a few seconds, faster than a racing car off the line. But this speed comes with limits. Cheetahs lack the strength of lions or tigers. Their claws don't fully retract, providing grip instead of stealth. The hunt is a gamble of energy, a chase that lasts mere seconds but costs nearly everything. Afterward, the cheetah must rest, panting in the grass, body trembling from effort. It's a fragile kind of dominance, swift, dazzling, but fleeting. In that narrow space between stillness and exhaustion, the cheetah shows us that nature's greatest advantages often come with exquisite vulnerability. Cougars whisper across entire continents, from Canada to Chile. Few wild animals have such a vast range as the cougar, also known as the mountain lion, puma, or catamount. It's the most widespread big cat in the Americas, roaming from the cold forests of Canada all the way to the southern tip of Chile. Despite this incredible reach, cougars are rarely seen. They move mostly at night, silent and solitary, leaving only tracks and echoes in the hills. Adaptability is their secret. They thrive in deserts, mountains, jungles, and suburbs alike, adjusting their diet and behavior to whatever landscape they claim. They can leap upward more than 15 feet and forward nearly 40 in a single bound. To encounter one is rare. To hear its eerie, human-like scream is unforgettable. The cougar's quiet resilience speaks of a species that endures not through dominance, but through patience, surviving wherever wildness still has room to breathe. Lions are the only truly social big cats, living in complex prides. Unlike the solitary lives of other big cats, lions live in tight-knit social groups called prides. Each pride may include multiple related females, their cubs, and one or more males who guard the territory. This structure gives lions a remarkable advantage in the open savanna, where teamwork makes hunting and defense far more effective. Females coordinate their hunts with precision, while males patrol boundaries and deter intruders. Within the pride, relationships are deep and emotional. Members groom, nuzzle, and greet each other with affectionate gestures. Cubs are often raised communally, and even adult males form strong coalitions, sometimes remaining bonded for life. This rare social organization makes the lion one of the most complex mammals outside of primates and elephants. Beneath their regal image lies something profoundly familiar, a pattern of loyalty, protection, and connection that mirrors our own social instincts. A tiger's stripes even appear on its skin beneath the fur. If you were to shave a tiger, which, of course, no one should ever do, the stripes would remain. They're not merely patterns in the fur, they're part of the skin itself. Each stripe corresponds to an area of differently pigmented cells, meaning the pattern exists at every layer of the coat. This deep biological imprint explains why a tiger's markings never fade or blur, even as the fur grows or sheds. Evolution shaped this design as perfect camouflage in the dappled light of forests and grasslands. Shadows and vertical lines break up the body's outline, making the tiger nearly invisible among reeds and trees. Scientists can identify individuals just by photographing their stripe patterns, which act as living barcodes in conservation studies. It's a quiet marvel, nature leaving its signature not only on the surface, but within the skin itself, a pattern born into every cell. The largest cat ever recorded weighed nearly as much as a small horse. The biggest tiger ever documented, a massive Siberian male, was estimated to weigh more than 850 pounds, about as much as a small horse. These giants, native to the snowy forests of eastern Russia, are living proof of how size can evolve in cold climates. Larger bodies conserve heat better, and the Siberian tiger's bulk, along with its thick coat and dense fat layer, make it the ultimate northern predator. When standing on its hind legs, such a tiger could easily look a grown human in the eye. Yet despite their size, they move with astonishing silence, padding through snow like drifting shadows. Encounters with these immense cats are rare now, their numbers dwindling. To imagine one walking through moonlit pines is to glimpse an ancient power, a reminder that the natural world still holds forces larger than we can fully comprehend. Big cats walk on silent, padded toes that mask every footfall. Every step a big cat takes is a calculated act of silence. They walk digitigrade, meaning on their toes, with thick, cushioned pads beneath each foot. These pads absorb impact and mute sound, letting the cat glide rather than stomp. The claws stay tucked away, hidden in protective sheaths that keep them sharp until needed. Even the arrangement of bones and tendons in their feet reduces friction and noise. To an animal being stalked, the silence is unsettling. There's no warning, no rustle, just the sudden presence of muscle and eyes. Scientists studying the physics of their stride found that big cats time each step so precisely that no unnecessary vibration passes through the ground. It's a level of precision that took millions of years to perfect, the art of motion so refined that even the wind struggles to hear it. Their retractable claws stay razor-sharp between hunts. Most big cats share one extraordinary trait: retractable claws. Unlike dogs, whose claws stay extended and dull from constant contact with the ground, cats can pull theirs inward when not in use. This simple ability keeps the claws sharp enough to grip, climb, and slice when the moment demands it. The mechanism is purely anatomical. Tendons contract to extend the claws and relax to hide them away. The exception is the cheetah, whose semi-retractable claws provide traction during high-speed chases. For the rest, those hidden blades are a secret weapon, always ready. In captivity, keepers sometimes find claw marks high above eye level, reminders of how agile and deliberate these predators are. The balance between protection and attack is elegant. Claws safe when walking, deadly when needed. Each cat carries a silent arsenal, always sheathed, always waiting, sharper than any knife forged by human hands. A tiger's canines can grow longer than a human finger. The tiger's fangs are extraordinary tools of evolution, curved ivory daggers reaching lengths of over 3 inches, often longer than an adult human's finger. These teeth aren't just for killing, they're precision instruments built for grip, puncture, and power. The canines interlock perfectly with the jaw structure, allowing tigers to deliver a lethal bite while maintaining a strong hold on struggling prey. They can pierce thick hide and bone with surgical efficiency. Unlike reptiles or sharks, whose teeth constantly regrow, big cats have one permanent adult set. Each tooth must last a lifetime. When a tiger loses a canine, it can struggle to hunt, a reminder that even apex predators have fragile vulnerabilities. Scientists studying fossil cats like Smilodon see the tiger's teeth as a surviving echo of ancient power, not exaggerated, but optimized for the living world. Its weaponry refined to perfection through necessity. Leopards' shoulder muscles are so strong they can drag an antelope up a tree. Leopards perform one of the most astonishing strength feats in the animal kingdom. With shoulders like coiled steel, they can hoist carcasses heavier than themselves up vertical tree trunks. This isn't a simple act of climbing, it's vertical weightlifting at a level that would exhaust almost any other predator. The adaptation serves a purpose. Leopards live among lions, hyenas, and other scavengers that would steal their kill if left on the ground. By caching food in branches, they dine undisturbed for days. The muscular architecture behind this feat is remarkable. Dense forelimb muscles, flexible joints, and semi-retractable claws that anchor into bark like hooks. Biomechanical studies show that leopards can exert pulling forces far beyond their body weight. To see one vanish upward, prey in tow, is to witness both raw physics and evolutionary finesse at work. The silent strength of survival expressed in motion. A cheetah's tail acts as a counterbalance during high-speed turns. When a cheetah runs, its entire body becomes an aerodynamic system. Its long, muscular tail isn't just decoration, it's a built-in steering device. At top speed, the cheetah's tail swings like a rudder, counteracting the torque of sudden turns and helping maintain balance as the body twists mid-air. During a chase, a cheetah can change direction faster than almost any land animal, sometimes adjusting course in a single heartbeat. High-speed footage reveals that tail movements anticipate shifts in momentum before the paws even touch the ground. This dynamic control allows the cheetah to pursue prey that zigzags unpredictably across the plains. Without that tail, the cat would tumble at its own velocity. Evolution turned balance into art. Every flick, every pivot, calculated with instinctive precision. It's grace at the limits of physics, agility born from the need to catch life before it escapes. The eyes of big cats glow in the dark, thanks to a mirror-like retinal layer. The eerie glow in a cat's eyes at night comes from a structure called the tapetum lucidum, Latin for bright carpet. It's a thin, reflective layer of tissue behind the retina that bounces light back through the eye, giving photoreceptors a second chance to capture every photon. This doubles their ability to see in near darkness, a vital edge for nocturnal hunters. The effect also produces that luminous green or golden shimmer when light catches the eyes at night. Scientists studying its composition found it contains microscopic crystals that reflect specific wavelengths, optimizing vision under starlight. In essence, big cats see the world as a landscape of faint contrasts invisible to us. To them, darkness isn't an obstacle, it's their element. What glows for us in headlights or flash photography is, for them, simply the light of their chosen world reflecting back. Whiskers help them sense air currents and the exact distance to prey. A big cat's whiskers, or vibrissae, are far more than decorative hairs. Each one is deeply embedded in the skin and connected to a network of nerve endings, so sensitive they can detect the faintest shift in air movement. This allows the cat to feel its surroundings, even in total darkness. When stalking, whiskers spread forward like antennae, measuring the exact space between the face and the prey. During a pounce, they relay real-time feedback about position and distance, helping the cat adjust its bite to hit precisely the neck or throat. Even blind cats can navigate complex environments purely through whisker sensation. Studies show each whisker can detect movement smaller than a human hair's width. It's a sensory map, constantly updating, a way of seeing without sight. In stillness, those whiskers rest in motion. They become extensions of awareness itself. Their skeletons are flexible, designed for both slinking stealth and explosive motion. Big cats have skeletons unlike any other large predators. Their spines are extraordinarily flexible, allowing them to contract and extend their bodies in a single stride. During a sprint, a cheetah's spine acts like a spring, flexing to double its stride length. For leopards and tigers, this flexibility allows them to coil into compact shapes, slipping unseen through foliage before exploding into motion. Even their shoulder blades aren't rigidly attached by bone but by muscle, granting greater range of movement. This blend of elasticity and power lets them climb, leap, and twist mid-air with astonishing control. Their bones are lightweight but strong, resisting fractures even under high impact. It's an evolutionary design of paradoxes: soft yet strong, light yet lethal, graceful yet immensely forceful. Every movement, from a crouch to a leap, is an orchestration of physics and instinct, honed to near perfection. A lion's roar can reach volumes rivaling thunder. When a lion roars, the air itself trembles. Recordings have measured the sound at over 100 decibels, comparable to standing beside a rock concert speaker or hearing thunder crack overhead. The structure of the lion's vocal cords allows them to produce these low, resonant sounds with minimal effort. Flattened, square-shaped folds vibrate more slowly, creating deep frequencies that travel astonishing distances. The roar can be heard by other lions as far as 5 miles away. Within prides, roaring serves as both communication and boundary setting, a sonic fence that keeps rival groups apart. The synchronized chorus of several lions is one of the loudest natural sounds on land. It doesn't just mark territory, it asserts unity. For those who hear it at dawn or dusk across the savanna, it's a reminder that power isn't always seen. Sometimes, it's only felt through the bones. Cheetahs can go from standing still to top speed in less than 3 heartbeats. Acceleration is the cheetah's superpower. In roughly 3 seconds, or less than 3 heartbeats at rest, it can reach speeds exceeding 60 miles per hour. That burst relies on a combination of extraordinary physiology. Enormous nasal passages draw in oxygen, An oversized liver processes energy, and powerful leg muscles propel the body forward with unmatched force. Unlike long-distance runners, cheetahs specialize in sprints so brief they border on self-destruction. Their bodies overheat quickly, forcing them to stop after about 30 seconds. Every chase is a gamble, a perfect, perilous alignment of reflexes and risk. High-speed cameras show how each stride covers over 20 feet of ground, the body airborne more than it's touching earth. The cheetah doesn't just run, it becomes motion itself, a blur between breaths. Its entire existence is built on those few breathtaking seconds of speed. Tigers love to swim and often soak in cool rivers. Unlike most cats, tigers are natural swimmers. They frequently bathe in lakes and rivers, especially in the heat of tropical forests. Some spend hours lounging in the shallows, their striped fur rippling in the water like living camouflage. Tigers have partially webbed paws and strong hind legs that make them capable of crossing wide rivers effortlessly. In India's Sundarbans mangrove forests, they swim between islands to hunt deer and boar, sometimes covering several miles at a time. Water also helps mask their scent, allowing them to approach prey undetected. Researchers have observed tigers hunting from the water, launching sudden ambushes with astonishing accuracy. This fondness for swimming sets them apart from nearly all other felines. For the tiger, water isn't a barrier, it's another realm to command. It's the quiet confidence of an animal perfectly at home in two worlds, land and liquid. Lions can sleep up to 20 hours a day. For all their might, lions are astonishingly lazy by human standards. A healthy adult may sleep or rest for nearly 20 hours every day. They hunt mostly at night, when temperatures drop and visibility favors them, and spend the rest of their time conserving energy. Their massive bodies generate heat quickly, and the African sun can be punishing. By resting in shade and minimizing movement, lions balance survival with efficiency. In a pride, different members take turns staying alert, ensuring safety while others sleep. Even when resting, lions remain socially connected. They sprawl together, grooming and touching, reaffirming bonds through gentle contact. This lifestyle isn't idleness, it's strategy. For a predator that depends on short bursts of intense energy, conservation is key. When a lion finally rises, every muscle is ready, every nerve sharpened, proof that even kings of the wild need long hours of stillness. Jaguars enjoy playing in water, unlike most cats. Jaguars stand out as one of the few big cats that truly love water. In their Central and South American habitats, they are often seen wading through rivers, lounging in pools, and even diving beneath the surface. Their muscular build and short, dense fur make them powerful swimmers. Some have been observed hunting fish, turtles, and even caimans, striking from below like aquatic predators. Researchers believe this affinity for water evolved from living in tropical regions dense with rivers and wetlands. For jaguars, water isn't a threat but an extension of their domain, a medium in which they move as effortlessly as they do through forest shadows. Their comfort in two elements gives them an edge over other predators that fear the depths. In the jungle, you might hear the splash of something large and silent, and know that somewhere nearby, a jaguar is watching. Leopards sometimes fake being asleep to ambush scavengers. Leopards are masters of deception. In some areas, researchers have documented a behavior that borders on intelligence and patience. The leopard will kill prey, feed partially, then lie beside it in apparent sleep. When hyenas or vultures approach, sensing an opportunity, the leopard suddenly attacks, reclaiming dominance. This tactic requires not just strength but strategic calm, an understanding of how other animals behave. It shows that big cats can manipulate not just their environment, but the expectations of other predators. Leopards are opportunists in every sense. Their cunning ensures survival in ecosystems filled with competition. Watching one feign indifference, eyes half closed but senses fully awake, is like seeing instinct turn into calculation. The forest seems still until it isn't. Then, in a blink, illusion becomes action, and the leopard reminds the world that patience can be a weapon. Snow leopards use their tails as fluffy scarves to stay warm. In the frozen reaches of Central Asia, temperatures plunge far below zero, but the snow leopard has evolved a simple, ingenious defense: its enormous tail. Thick with dense fur and nearly as long as its body, the tail acts as both bounce and blanket. When resting, the snow leopard curls it around its face and paws, creating a cocoon of warmth that traps body heat. The tail also stores fat, adding insulation and energy reserves. During movement, it helps the cat balance on narrow ledges and leap across icy gaps. The texture of the fur is among the softest of any mammal, designed to protect against brutal wind. Early explorers who found tracks high in the Himalayas often mistook them for myths. Few imagined a creature so well adapted to such heights. Every loop of that magnificent tail tells a story of survival written in fur. Cheetahs chirp, purr, and yelp, but they cannot roar. Unlike lions and tigers, cheetahs lack the specialized larynx needed to produce a roar. Instead, their vocal range includes chirps, purrs, growls, and yelps. Sounds more like a songbird than a predator. The chirps are especially distinctive, high-pitched calls used by mothers to communicate with cubs across tall grass. They can also purr continuously, much like domestic cats, a trait rare among large felines. Scientists studying their vocal anatomy found that the hyoid bone in the throat is ossified, rigid, preventing the deep vibrations that create a roar. This gives cheetahs a voice entirely their own, lighter and more expressive. In captivity, handlers describe their calls as friendly, even chatty. It's a gentle sound from an animal built for violence, another reminder that nature's fiercest forms often hold unexpected softness. The cheetah's voice, delicate yet distinct, belongs entirely to itself. Cougars make eerie screams that once inspired myths of ghosts. Few animal sounds unsettle humans like the scream of a cougar. It's a long, wavering cry that echoes through forests and mountains, eerily similar to a human voice. Early settlers described it as the wailing woman of the woods, believing spirits haunted the wilderness. In truth, these calls are territorial or mating signals, the cougar's way of announcing its presence across vast distances. The sound can travel for miles, bouncing off cliffs and valleys, making its origin hard to pinpoint. Biologists think the scream evolved to carry through rugged terrain where visibility is poor. At night, the cry pierces the silence, sending ripples through every living creature that hears it. For humans, the reaction is instinctive. Our brains recognize something both familiar and alien. It's the wilderness reminding us that we are guests in a world still ruled by older, quieter powers. Big cats can see up to 6 times better in low light than humans. When dusk falls, the world of the big cats comes alive. Their eyes contain far more rod cells than ours, the photoreceptors specialized for low light. Combined with a reflective retinal layer called the tapetum lucidum, this gives them extraordinary night vision, up to 6 times more sensitive than human sight. They can detect movement in near darkness, tracking prey by the faintest flicker. Even the shape of their pupils helps. Round in lions, but more vertically elongated in some leopards for better depth perception in variable light. Scientists studying feline vision found that cats can perceive subtle contrasts invisible to humans, effectively seeing the wind through the grass. To us, twilight dims the world to them. It opens. Their gaze belongs to the hour between day and night, a time when light bends, shadows stretch, and the hunt begins. Some lions have dark manes that signal high testosterone and status. The mane of a male lion is more than decoration. It's a biological billboard. Darker, fuller manes often indicate higher testosterone levels, better nutrition, and superior health. Females tend to prefer males with such manes, as they signal strength and genetic quality. Rivals, meanwhile, are more likely to avoid challenging a dark-maned male, recognizing the risk. Scientists studying prides in Kenya observed that males with darker manes not only sired more cubs, but also held territories longer. The mane also serves a practical purpose: protection. During fights, it cushions the neck and head against bites. Yet growing and maintaining such a mane comes with costs. Heat retention in the African sun can be intense. Some lions in hotter regions have shorter or lighter-colored manes, a trade-off between display and comfort. Every mane, in its shade and shape, tells a story of balance between beauty and survival. Tigers mark their territory with tree scratches higher than most humans can reach. Tigers are solitary animals, and their territories are enormous, often spanning dozens of square miles. To communicate boundaries, they use scent marking, urine sprays, and deep scratches on trees. Some of these marks appear more than 9 feet off the ground, higher than most humans can reach. The height serves 2 purposes. It signals the tiger's size to potential rivals, and it spreads scent through glands between the paw pads. Researchers have observed tigers stretching to their full length, raking claws down the bark to leave both visual and chemical messages. Each mark says, "This place is taken." Other tigers can read these cues with astonishing detail, identifying sex, reproductive status, and even individual identity. The forest becomes a vast, invisible conversation in scratches and scents, written on trees older than the cats themselves. To walk among them is to read the wild's quiet language. The first true big cats evolved roughly 10 million years ago. The lineage that would become the great roaring cats, lions, tigers, leopards, and jaguars, split from smaller ancestors about 10 million years ago. Fossils from that period show early members of the Panthera genus beginning to develop the heavy skulls, muscular jaws, and flexible larynxes that distinguish big cats today. They spread quickly, adapting to new continents as climates shifted and prey species evolved. Ancient ancestors once roamed from Africa through Europe and deep into Asia, long before glaciers carved the modern world. Their bones tell a story of refinement, not reinvention, slow changes shaped by survival across countless generations. The sleek hunters we recognize now are echoes of those first prototypes, creatures whose instincts were already written in their bones. 10 million years may separate them from us, but when a lion's eyes catch the light, that ancient design still looks back. Smilodon, the saber-toothed cat, once ruled the Ice Age plains. During the last Ice Age, North America belonged to Smilodon fatalis, the famous saber-toothed cat. Its elongated canines could reach nearly 8 inches in length, curved and serrated like ancient blades. Yet Smilodon wasn't built for speed. It was a stocky ambush predator, using immense forelimbs to pin prey before delivering a precise, fatal bite. Fossils found in the La Brea tar pits reveal that they hunted giant ground sloths, bison, and young mammoths. Despite their fearsome appearance, those long teeth were surprisingly fragile, suited for cutting flesh rather than crushing bone. When large Ice Age herbivores vanished, Smilodon followed, unable to adapt to smaller, faster prey. Its extinction about 10,000 years ago closed one of evolution's most dramatic chapters. The living big cats are its surviving relatives, leaner and more versatile, inheritors of an empire once ruled by a creature of prehistoric grace and power. Modern tigers share a distant ancestor with house cats. It's easy to see tigers as entirely separate from domestic cats, yet they share a surprisingly close evolutionary link. Genetic sequencing shows that all living felines, from your household tabby to the Amur tiger, descend from a common ancestor that lived about 10 to 12 million years ago. That early cat likely resembled a small, forest-dwelling predator with retractable claws and keen night vision. Over time, different branches of this lineage adapted to unique niches. Some grew larger to hunt hoofed mammals, while others specialized in small prey. Despite the size gap, domestic cats still display many tiger traits: the slow-motion stalk, the tail flick before a pounce, even the sideways threat display. Watching a kitten practice hunting with a toy mouse is like seeing a miniature, harmless echo of evolution at work, a family resemblance that spans millions of years. Lions and leopards diverged from a common ancestor only a few million years ago. Though lions and leopards seem vastly different, one social and bold, the other solitary and secretive, DNA tells a closer story. Their evolutionary paths split roughly 3 to 4 million years ago. Early fossils from Africa show cats with intermediate traits, long limbs like leopards, but broader skulls resembling lions. As climates shifted and grasslands replaced forests, one lineage adapted to open hunting in groups, while the other specialized in stealth and climbing. The result was a divergence not just in body shape, but in behavior, a genetic fork in the road that produced two of Earth's most iconic predators. Even now, their territories overlap, and sometimes their behaviors blur. Leopards can roar faintly like lions, and lions occasionally hunt alone. Evolution rarely draws hard lines. It sketches possibilities, then lets the environment decide which path survives. The cheetah's slender body reflects a completely separate evolutionary path. Cheetahs aren't part of the panthera group that includes lions, tigers, and leopards. Instead, they belong to their own distinct branch, having diverged much earlier in feline evolution. Genetic evidence suggests their ancestors emerged more than 5 million years ago, evolving towards speed rather than strength. Over time, cheetahs lost the flexible larynx that allows roaring and traded powerful bone density for lightweight agility. Their long legs, narrow waists, and oversized heart and lungs make them the most specialized sprinters on Earth. Fossil records reveal that prehistoric cheetahs once roamed even Europe and North America before disappearing around the last ice age. The modern cheetah is a surviving fragment of that ancient line, a living fossil of speed. Its grace reminds us that evolution doesn't favor only the strongest or loudest. Sometimes it chooses precision and timing as its masterpiece. The snow leopard's skull is specially adapted for thin mountain air. High in the Himalayas and across Central Asia, the snow leopard thrives in air so thin it would leave most mammals gasping. Its skull reveals how large nasal cavities warm and humidify freezing air before it reaches the lungs, while broad sinuses increase oxygen absorption. The skull's unique shape also provides attachment points for powerful jaw muscles, giving it the strength to hold on to prey on steep slopes. Even the shape of its chest cavity supports deep breathing at altitude. Scientists have compared its oxygen-binding hemoglobin to that of yaks and Tibetan antelope, all adapted to survive where oxygen levels are less than half those at sea level. The result is a predator perfectly tuned to its realm of cliffs and clouds. The snow leopard isn't merely surviving in thin air. It has turned the edge of the sky into its natural home. The jaguar may have originated in Asia before crossing into the Americas. For decades, Paleontologists believed jaguars were native only to the New World. But fossil evidence from China dating to around 2 million years ago suggests otherwise. These ancient cats resemble early jaguars, implying that their ancestors may have crossed the Bering Land Bridge during a period of lower sea levels. Once in the Americas, they evolved into the powerful rainforest hunters we know today. Over time, the jaguar's range stretched from the southwestern United States down to Argentina, adapting to deserts, jungles, and wetlands. Its robust skull and unique killing technique, a direct bite through the skull, may reflect evolutionary influences from its Old World relatives. If true, the jaguar's journey ranks among the most extraordinary migrations in mammalian history, a silent traveler from Asia that became a symbol of American wilderness, written into both the land and ancient air. Human myth. Some scientists think cougars represent one of the oldest cat lineages in the New World. Genetic studies show that cougars, or pumas, may trace their origins back millions of years within the Americas, long before lions or leopards arrived from Eurasia. Fossils of their early ancestors appear in North American strata dating to nearly 4 million years ago. Unlike the roaring cats, cougars retained features closer to smaller felines, rounded skulls, flexible voices, and solitary behavior. Their success comes from adaptability. They can thrive in nearly every habitat, from deserts to snow-covered peaks. Researchers believe their ancient lineage helped them endure the climatic upheavals that wiped out so many other large predators. Today's cougars carry genetic echoes of those early survivors. They are not relics of the past, but living evidence that evolution's oldest designs can still outlast time, quiet endurance outcompeting spectacle in the long history of life on Earth. The Panthera lineage gave rise to the world's roaring cats. The genus Panthera, home to lions, tigers, leopards, and jaguars, owes its name to a single evolutionary innovation: the ability to roar. Genetic and anatomical studies suggest that all four share a common ancestor that appeared around 6 million years ago. Over time, this group diversified across continents, each adapting its roar and physique to different environments. Fossils from Asia hint that early Panthera species may have been smaller, but possessed the unique hyoid bone structure that allowed low-frequency calls. As they spread, selective pressures shaped distinct traits: mane growth in lions, stripes in tigers, rosettes in leopards, and powered jaws in jaguars. The Panthera lineage is still evolving. New DNA research continues to refine how these species split and spread. Their shared ancestry links them not by territory or behavior, but by voice, the deep, resonant signature that defines their family. The ability to roar evolved from a flexible bone in the throat. Roaring is possible thanks to a specialized structure in the throat called the hyoid bone. In most cats, this bone is solid, allowing them to purr continuously. But in lions, tigers, leopards, and jaguars, the hyoid is only partially ossified, flexible enough to vibrate at very low frequencies. This flexibility, combined with large vocal folds and powerful chest muscles, enables their deep, rolling calls. The trade-off is that these species cannot purr like smaller cats can. Evolution turned a simple anatomical variation into an acoustic weapon, letting these predators communicate across miles. Scientists studying the physics of roaring discovered that air pressure and vibration synchronize to produce harmonics similar to musical instruments. Every roar you hear is both anatomy and resonance, bone, air, and muscle working as one. It's the sound of evolution itself, shaped into a voice that can move the earth. Each big cat species has its own signature call. Every species of big cat speaks with a distinct voice. Lions roar in rhythmic bursts, tigers in deeper rolling sequences, and leopards emit a sawing rasp that truly resembles a hand saw on wood. Jaguars grunt and cough in rough pulses, while snow leopards produce soft huffs called chuffs. These differences arise from variations in throat anatomy, vocal fold tension, and lung capacity. Communication is crucial in the wild, for marking territory, attracting mates, and maintaining social bonds. Researchers analyzing these vocalizations found that even within a species, individuals have identifiable accents, allowing recognition across distances. It's not random noise, it's structured language tuned to landscape and lifestyle. To us, these sounds might seem primal, but to the cats, they are conversations. The wilderness speaking in dialects shaped by time, place, and purpose. Tigers use infrasound, low-frequency rumbles humans cannot hear. Beyond the audible roar lies a hidden frequency, infrasound. Tigers produce these deep rumbles below 20 Hz, too low for human ears to detect. Field studies with specialized microphones have revealed that these low tones can travel through dense forests and even the ground itself, reaching other tigers miles away. Infrasound serves as both communication and intimidation. It can be felt more than heard, vibrating in the chest of nearby animals. Some researchers suggest it helps coordinate movement during mating or territorial patrols, acting like a subsonic beacon. Even zoo visitors occasionally report feeling uneasy without realizing why. They're sensing those vibrations. This remarkable adaptation gives tigers a private channel of communication, one that slips beneath human perception. The forest, it seems, is filled with voices we cannot hear, and the tigers is one of the most commanding among them. Leopards have a sawing call that sounds like someone cutting wood. Leopards rarely roar, but when they do vocalize, the sound is unmistakable. A harsh, rhythmic rasp that mimics a saw biting through timber. This sawing call is used to advertise territory and attract mates, often echoing through forests at dawn and dusk. Each leopard saw pattern carries unique timing and pitch, functioning like a vocal fingerprint. The sound is produced as air passes over the vocal cords during both exhalation and inhalation, creating a continuous rasp. To human ears, it can sound startlingly mechanical, a reminder that nature's designs often overlap with the world of tools and texture. Researchers tracking these calls use audio recorders to map leopard territories without ever seeing the animals. The sawing call is practical, efficient, and hauntingly effective, an auditory signature that blends perfectly with the forest's rhythm, marking presence without revealing location. Lions' roars can synchronize in choruses that strengthen social bonds. When a pride of lions roars together, the sound becomes something more than communication. It's unity made audible. Coordinated roaring sessions often occur at dusk or dawn, when sound travels farthest across the savanna. Studies show that group roaring helps reinforce territory boundaries and solidify pride cohesion. Each lion's voice has subtle variations in pitch and rhythm, and when combined, the effect resembles a layered chorus. Neighboring prides sometimes respond, creating a rolling dialogue of thunder across miles of grassland. The synchronization isn't accidental. Individuals adjust their timing instinctively, much like a choir blending voices. Behavioral ecologists have found that these collective roars can reduce territorial disputes by reminding rivals that a pride is large and alert. To witness it is to feel the pulse of a living community, sound turned into strength, echoing through the open night. Cheetahs communicate through chirps that resemble bird calls. Cheetahs defy expectations even in their voices. Instead of deep roars, they emit bright, high-pitched chirps that sound almost like songbirds. Mothers and cubs use these calls to stay in contact across tall grass, while adults may chirp during courtship or when greeting one another. Field researchers describe the sound as a mix between a whistle and a bird call, capable of carrying surprising distances. The cheetah's vocal cords and rigid hyoid bone restrict low frequencies but allow quick, precise bursts of sound, perfect for short-range communication. In dense savanna vegetation, these chirps cut through background noise without alarming prey. To hear it is uncanny, a fragile, cheerful sound from a body built for lethal speed. The contrast encapsulates the cheetah's nature: light, agile, and unpredictable, a creature of contradictions that speaks softly while moving faster than the wind itself. Jaguars grunt, cough, and even produce a sound called a saw. The jaguar's voice bridges the gap between a roar and a growl, a deep, throaty series of grunts often described as a sawing call, similar to that of the leopard, but rougher and shorter. Males use this sound to announce presence and attract females, particularly in dense jungle where visibility is limited. The sound carries astonishingly well through humid air, sometimes traveling more than a mile. Jaguars also produce a unique cough-like roar during confrontations, a rapid pulsing sound that vibrates through the forest canopy. Their varied repertoire reflects their environment. Short, powerful bursts suit thick vegetation better than long roars. Acoustic studies show that each jaguar's saw has distinct intervals, allowing recognition among neighbors. It's the forest's hidden language, communication carried on vibrations, threading through trees older than civilization itself. Snow leopards make soft huffs, known as chuffing. Snow leopards lack the anatomy to roar, but they express themselves through a gentler sound called chuffing, a short burst of air through the nostrils, often used as a friendly greeting. In zoos and remote camera traps, chuffing is observed between mates, mothers and cubs, and even toward humans they trust. It conveys calm and reassurance rather than aggression. Unlike growls or hisses, a chuff carries no threat. It's the feline equivalent of a smile. Scientists studying their social behavior note that this low-intensity vocalization may help maintain peace in sparse populations, reducing unnecessary conflict across vast, lonely ranges. To hear a snow leopard chuff is rare, a soft exhalation of breath in frozen air, warmth briefly touching the cold. It's the gentlest sound ever produced by a predator capable of extraordinary power. Scent marking is as vital as sound, a cat's invisible language. The big cats, communication doesn't rely on voice alone. They use scent, complex chemical signatures left behind on trees, rocks, and trails to broadcast information. Glands near the face, tail, and paws secrete oils rich with hormones that reveal identity, sex, and even emotional state. Urine spray adds another layer, acting like a territorial signature. Other cats reading these marks can discern not just who left them, but how recently. In dense habitats where vision and sound are limited, scent forms a map of presence that lasts for days. Researchers compare it to written correspondence, messages exchanged in time rather than space. The forest, savanna, or tundra becomes a living network of invisible signals. To us, it's imperceptible, but to them, it's language as clear as speech, the wild written in scent rather than sound. Each scent mark carries personal chemical signatures unique to the individual. When a lion sprays or a leopard rubs against a tree, it's leaving a chemical fingerprint as distinct as a human's. Analysis of these secretions reveals a mix of volatile compounds that vary between individuals. Some are linked to diet, others to genetics, but together they create a scent profile impossible to replicate. In experiments, cats recognize the marks of familiar neighbors and react differently to strangers, sometimes cautious, sometimes aggressive. This olfactory communication reduces unnecessary conflict. A single whiff, can prevent dangerous encounters. For biologists, studying these scent molecules provides insight into territory overlap and population health. It's a form of identity that predates written language by millions of years, a record not on paper, but in air and bark. Every breeze in a lion's territory carries fragments of its autobiography. Big cats use whisker positions and tail movements as silent communication. Body language is another layer of feline dialogue. Whiskers angled forward signal focus or aggression flattened backward means fear or submission. A slow flick of the tail tip can indicate irritation, while sweeping arcs may show curiosity or playfulness. Within prides or between mates, these subtle gestures prevent conflict and strengthen bonds without sound. Cubs learn them early, watching adults interact and mimicking postures during play. Researchers filming slow-motion interactions note that even slight whisker twitches correspond with eye contact and breathing patterns, a quiet, non-verbal symphony of emotion. For animals that rely on stealth, silence is safer than speech. Their entire bodies become tools of communication, translating thought into motion. To see it is to glimpse the grace of instinct shaped into language, every whisker, every tail flick, a sentence in the unspoken conversation of the wild. A tiger's forelimbs are strong enough to break the spine of large prey. Few muscles in the animal kingdom rival the power of a tiger's front limbs. Built for grappling rather than sprinting, they contain thick layers of fast-twitch fibers capable of delivering crushing force. When a tiger pounces, it wraps its forelegs around the prey's body, using momentum and sheer strength to pull it down. The claws sink in, the body twists, and a single strike of the paw can knock an adult deer off its feet. Researchers examining tiger skeletons found unusually broad shoulder blades and reinforced humerus bones, adaptations for immense leverage. In rare observations, tigers have broken the spine of large ungulates instantly, ending the hunt in one decisive movement. It's a demonstration of precision, not brutality. Every muscle acts in harmony. To watch one move is to see biology's idea of perfect balance between force and control, power delivered with quiet certainty. Big cats' tongues are covered in backward curving spines for scraping meat. A close look at a big cat's tongue reveals thousands of tiny hook-shaped structures called papillae. These keratinized spines curve backward like miniature claws, giving the tongue a rough, sandpaper texture. When the cat licks meat from bone, each papilla acts like a comb, gripping tissue and pulling it free. The same structures help groom fur, remove parasites, and spread natural oils through the coat. Under a microscope, the papillae resemble tiny scoops, efficient tools for cleaning and feeding alike. Engineers studying their geometry have even modeled new types of brushes and fabric tools after them. In the wild, this specialized tongue ensures that nothing is wasted. A lion can strip a carcass almost perfectly clean. It's an everyday miracle of design, not dramatic, just brilliantly effective, proof that evolution refines even the smallest details until nothing is left to chance. Their hearts and lungs are proportionally massive for sudden bursts of power. Inside every big cat beats a cardiovascular system tuned for brief explosions of effort. Their hearts and lungs are larger relative to body size than most mammals, capable of flooding muscles with oxygen in seconds. When a lion sprints or a leopard leaps, heart rates can triple almost instantly, pushing blood through arteries built for flexibility and strength. Lungs expand rapidly, supported by broad ribs and strong intercostal muscles that act like bellows. The payoff is a few precious moments of supreme performance: the sprint, the tackle, the pounce. But the cost is equally high. After each burst, the cat must rest. its body cooling and recalibrating. This balance between endurance and power defines their hunting style. They are not marathoners but ambush specialists, relying on one perfect moment. Beneath that calm exterior lies a machine capable of instant, explosive transformation. The cheetah's lightweight bones and enlarged nostrils maximize oxygen flow. Speed begins with air. The cheetah's skull and skeleton are shaped to move oxygen as efficiently as possible. Enlarged nasal passages channel huge volumes of air to oversized lungs, while lightweight bones reduce energy cost. During a sprint, its respiratory rate can exceed 150 breaths per minute, roughly 2 every second. The spine stretches and compresses like a spring, pushing the ribcage to pump air in rhythm with each stride. Even the nasal cavities are lined with cooling surfaces to prevent overheating. Scientists call this aerobic architecture. Every structure serves airflow. Yet this perfection has limits after a chase. The cheetah's body overheats rapidly, forcing it to rest and pant until its temperature drops. Evolution traded durability for acceleration. The result is breathtaking. An organism sculpted by air and motion. A body built to touch the edge of physics, if only briefly. Snow leopards' paws act like snowshoes on icy slips. High in the Himalayas, snow leopards walk where few creatures dare. Their wide, fur-covered paws spread their weight evenly across snow, functioning like natural snowshoes. The thick fur between their toes insulates against ice and provides traction on slippery rock. Beneath that softness lies a hidden layer of muscle and tendon designed for grip and shock absorption. When they leap between cliffs, sometimes spanning more than 40 feet, these paws land silently, absorbing the full force of the fall. Tracks found in remote valleys show how their gait adapts to terrain. Shorter strides on steep ascents, longer ones on open slopes. This quiet engineering keeps them stable in a world of thin air and shifting snow. Each step is careful but confident, a pattern learned over millions of years. To follow those prints is to trace the path of a creature perfectly suited to the sky's cold floor. Lions' golden coats blend seamlessly with the African savanna. The tawny color of a lion's fur isn't random beauty, it's practical design. The golden hue mirrors the dry grasses and dusty soil of their savanna home, helping them vanish into the landscape. Under dawn or dusklight, a resting lion becomes nearly invisible until it moves. Cubs are born with faint spots that fade as they grow, a relic of ancestral camouflage once useful in denser habitats. Even the texture of their fur reflects adaptation. Coarse guard hairs protect against sun and thorns, while softer underfur regulates temperature. In certain regions, lions develop slightly darker coats, blending with the reddish earth of their surroundings. Its camouflage evolved not for stealthy stalking alone, but for survival during long, exposed hours in open country. The lion may be a symbol of boldness, yet its success often begins with invisibility, hidden in plain golden view. Leopard spots form rosettes that mimic dappled forest light. The leopard's pattern of rosettes, clusters of dark spots encircling lighter fur, is more than decoration. It's mimicry of light itself. In forests and thickets, sunlight filters through leaves in scattered patches. The rosettes break up the cat's outline, blending body contours into this shifting mosaic. Even motion becomes disguised, the eye can't follow a shape that merges with shadows. Every population shows slight variation in pattern, tuned to habitat. Smaller rosettes in dense forests, larger ones in open terrain. Infrared imaging reveals how these patterns disrupt not only visible color, but also thermal outlines, confusing both prey and potential competitors. Biologists use computer models to study how this fractal camouflage evolved. finding parallels with patterns in fish and snakes. The result is nature's quiet illusionist, a predator painted not to be seen, but to move invisibly through a world of moving light. Jaguars' rosettes have tiny central dots, their unique signature. At first glance, jaguars resemble leopards, but look closer and the difference reveals itself in the detail. Each jaguar rosette contains a small central spot, a unique signature distinguishing the species. This subtle feature may aid recognition among individuals, though its origin lies in evolution and environment. In the dim light of tropical forests, those dotted rosettes better imitate the play of sun through dense foliage. The jaguar's heavier build and thicker coat further differentiate it from its cousin, turning the same basic pattern into a tool for stealth in an entirely new setting. Even genetic analyses confirm distinct pigment-regulating genes responsible for these intricate arrangements. Conservationists use the rosette patterns to identify and track individuals with photographic precision, proving that no two jaguars wear the same design. Every spot, every dot, is a personal signature, a living fingerprint, inked in gold and black. Tigers' coats range from deep orange to nearly white. Though we imagine tigers as bright orange with black stripes, their coats actually vary widely depending on habitat and genetics. In humid jungles, fur tends to be darker and richer in color, providing contrast in shadowed vegetation. In northern forests and snowy regions, tigers grew paler, with thicker fur and faint striping. Some individuals appear almost golden, others reddish, and rare ones show bluish undertones described in old accounts as Maltese tigers. These variations arise from subtle shifts in pigment-producing cells. The orange hue, contrary to popular belief, helps camouflage the tiger from prey that see in limited color to deer or boar. It appears as dull greenish-brown. Under moonlight, that fiery coat fades to soft silver. Nature's palette, as always, is functional first, beautiful by coincidence, color serving survival, beauty emerging as the fortunate side effect of purpose. Some tigers are completely white, the result of rare recessive genes. White tigers are not a separate species, but the product of a rare genetic variation that suppresses red and yellow pigments, leaving black stripes over creamy white fur. The trait is recessive, meaning both parents must carry the gene for it to appear. In the wild, this combination occurs extremely rarely, though historical records suggest they once roamed parts of India. Modern white tigers often descend from a handful of individuals bred in captivity, which has unfortunately led to inbreeding and health problems. Despite controversy, their striking appearance continues to fascinate the public and scientists alike. Geneticists study them to understand pigment control and pattern formation across all mammals. In essence, the white tiger is evolution's experiment, a natural variation that dazzles the eye but survives only through chance. In the snowy forests of imagination, it remains the ghost of a gene expressed in brilliance. Ancient kings kept lions as living symbols of power. Long before lions appeared on national emblems or coins, real ones paced behind palace walls. From Mesopotamia to Persia and ancient Egypt, rulers kept lions as proof of dominion over nature. Reliefs from Nineveh show Assyrian kings engaging in lion hunts, carefully staged rituals meant to display bravery and control. Egyptian pharaohs bred them as royal companions, associating them with the sun god Ra. In ancient Rome, lions became the ultimate spectacle in arenas, their presence symbolizing empire and authority. Even in medieval Europe, where no wild lions lived, they adorned coats of arms as icons of nobility. Across cultures, the lion's image became shorthand for courage, leadership, and divine strength. Yet behind that symbolism stands the real animal, social, intelligent, and vulnerable, whose majesty inspired humanity's oldest stories of power. and whose roar still echoes through our collective memory. Tigers appear in myth from India to China as creatures of cosmic balance. In Asian mythology, the tiger represents strength, protection, and natural order. In Chinese cosmology, the white tiger is one of the 4 celestial guardians, ruling the western sky and symbolizing autumn. In India, the goddess Durga rides a tiger into battle, signifying power used with purpose. Throughout Southeast Asia, tiger spirits guard forests and mountains, maintaining balance between humans and the wild. Even modern festivals still honor this connection. The tiger remains a bridge between the visible world and the unseen. Anthropologists note that such myths often mirror ecological realities. The tiger's role as apex predator keeps ecosystems stable, a truth reflected in ancient stories long before ecology became bee. Science. To revere the tiger was to acknowledge the balance of life and death, chaos and order, the unspoken understanding that survival itself depends on respecting the striped guardian of the earth. The leopard was sacred to the Egyptian god Osiris. In ancient Egypt, the leopard held spiritual weight far beyond its physical presence. Priests, serving the god Osiris, lord of the afterlife, wore leopard skin cloaks during sacred rites. The spotted pelt symbolized the night sky dotted with stars, representing transition from life to death. The leopard's grace and stealth were seen as qualities necessary for journeying between worlds. Archaeologists have uncovered tomb paintings depicting these robes in vivid detail, each spot rendered like a celestial map. To the Egyptians, wearing the skin was not conquest, but transformation, the priest taking on the cat's attributes to move between realms. This deep association between feline power and spiritual passage persisted for centuries, influencing later African and Mediterranean rituals. Even now, fragments of leopard symbolism linger in art and language, echoes of a civilization that saw divinity hidden beneath a patterned coat. Jaguars were revered by the Maya as lords of the underworld. In the ancient Maya world, the jaguar wasn't just an animal, it was a god. Depicted in carvings, murals, and royal tombs, the jaguar symbolized strength, night, and the passage between life and death. The Maya believed the sun itself transformed into a jaguar each evening to journey through the underworld before rising again. Kings adorned themselves with jaguar pelts to claim divine favor, and warriors took jaguar names to channel its power. Archaeological finds reveal entire temples dedicated to jaguar deities, their imagery woven into calendars and cosmology. To them, this big cat embodied both the danger and necessity of darkness, a reminder that the world's balance depends on cycles of light and shadow. Every spotted pelt represented the stars scattered across the night sky, and every roar was the voice of a god moving through the unseen corridors of time. In some Native American stories, cougars taught humans how to hunt. Among several indigenous peoples of North and South America, the cougar, or mountain lion, plays the role of teacher. Legends describe how early humans learned patience, stealth, and respect for prey by watching the cougar move. In stories of the Zuni and Hopi, the cougar is a guardian of the north, symbolizing strength through silence. Some tribes believed the spirit of the cougar guided hunters, ensuring balance between taking and giving back. These tales weren't superstition, but ecological wisdom passed through generations. By personifying the cougar, communities remembered to move carefully, to take only what was needed, and to maintain harmony with the land. Modern biologists studying predator-prey dynamics often find parallels in these old lessons. The cougar's mythic role as mentor captures a truth both scientific and spiritual. Survival thrives where respect for the natural order endures. Cheetahs were once trained by royalty for hunting gazelles. Long before modern falconry, ancient rulers in Persia, India, and Egypt practiced a form of coursing with trained cheetahs. Unlike other big cats, cheetahs adapt well to human presence and can be tamed from a young age. Royals kept hundreds in ornate compounds, transporting them on horseback or in carriages to open fields for hunts. When released, the cheetah would chase down gazelles or hares with breathtaking speed, returning docilely to its handler afterward. Historical accounts describe Akbar the Great of India keeping more than 1,000. These cats were never truly domesticated. Breeding in captivity proved difficult, but they became living symbols of elegance and precision. The tradition faded with the decline of empires, leaving behind mosaics, manuscripts, and reliefs depicting spotted hunters beside their human companions. Reminders of a time when royalty measured status not by jewels, but by grace in motion. The word panther comes from ancient Greek, meaning all beasts. The term panther has traveled through languages and meanings for over 2,000 years. Derived from the Greek panthera, combining pan-all and therian beast, it originally referred to a mythic creature that could attract every animal with its sweet breath. Over time, the name became associated with spotted big cats, particularly leopards. In the Middle Ages, naturalists used panther as a catch-all term for large felines, and today it often describes melanistic leopards or jaguars, those with black coats where rosettes hide in shadow. The linguistic journey mirrors our fascination with these animals, part myth, part science. Each age redefined the word to fit its understanding of the wild. When we say Black Panther, we're really invoking centuries of storytelling, a reminder that language, like evolution, adapts, carrying echoes of wonder through every translation. Medieval bestiaries saw lions as symbols of resurrection and courage. In Europe's illuminated manuscripts, lions roamed the pages as moral teachers rather than animals. Medieval bestiaries, illustrated books of creatures real and imagined, described the lion as noble, wise, and Christ-like. Writers claimed lions slept with their eyes open, symbolizing divine vigilance, and that cubs were born dead until revived by their father's breath on the third day, an allegory of resurrection. These stories spread across monasteries and royal courts, shaping heraldry and literature for centuries. Although few Europeans had ever seen a lion, its imagined virtues filled their art and faith. The lion's image evolved from predator to parable, a mirror reflecting human ideals of bravery and rebirth. Even today, sculptures outside cathedrals and castles carry that same expression: calm, watchful, eternal. The echo of a story written not in science, but in symbolism. Snow leopards appear in Himalayan folklore as mountain spirits. In the high villages of Nepal, Bhutan, and Tibet, snow leopards are more than elusive animals. They are spirits of the mountains. Folk tales describe them as protectors of sacred peaks, guardians ensuring humans do not overhunt or defile the land. To see one was considered a blessing, a sign that the mountains had accepted your presence. Monks sometimes painted their forms in temple murals, blending them with clouds to show their ethereal nature. Even modern conservationists find that these beliefs aid protection efforts, reverence discourages poaching, and fosters coexistence. The snow leopard's ability to vanish into mist reinforces its legend, part animal, part apparition. In thin air, where sound and time feel slower, it's easy to understand why generations imagined something supernatural moving among the cliffs, a whisper of fur and silence belonging to both earth and sky. Big cats have inspired art and iconography for thousands of years. From prehistoric cave walls to modern murals, Big cats have stalked through human imagination since the dawn of creativity. The oldest known depiction, a lion-headed figurine carved over 30,000 years ago, may be the first mythic hybrid ever created. In ancient China, bronze tigers guarded tombs in Africa, leopard skins adorned kings in Europe, heraldic lions guarded banners. Across centuries, artists captured not only their power, but their paradox, ferocity and grace combined in one form. Even today, films, logos, and sculptures use their likeness to express courage, freedom, and beauty. Neuroscientists suggest our fascination may stem from an ancient instinct, admiration mixed with respectful fear. Whatever its origin, the image endures. To draw or carve a big cat is to participate in a lineage of awe that began when humans first saw eyes shining in firelight and decided to remember. Melanism gives some leopards and jaguars jet-black coats. Melanism is a rare genetic trait that causes an overproduction of dark pigment called melanin, giving certain leopards and jaguars entirely black coats. Under sunlight, you can still see faint rosette patterns shimmering through the darkness, ghostly traces of their usual markings. Scientists believe this mutation offers an advantage in dense forests, where darkness provides better camouflage for ambush hunters. In jaguars, the melanistic gene is dominant, while in leopards, it's recessive, a fascinating example of parallel evolution, producing the same adaptation through different genetic routes. Locals in Asia call black leopards shadow panthers, while in South America, black jaguars are sometimes called onsars pretas. Their striking appearance once gave rise to myths of supernatural cats that vanished in the night. Today, camera traps confirm that these black panthers still roam wild jungles, elegant reminders that even within a species, nature keeps painting new variations. White lions exist only in a few reserves in South Africa. White lions are among the rarest big cats on Earth. Unlike albinos, they retain pigmentation in their eyes and skin. Their pale coats result from a recessive gene known as the chinchilla mutation, which filters out most of the golden hue. Historically, they appeared only in the Timbavati region of South Africa, where local legends described them as sacred messengers. In the wild, their coloration can make camouflage difficult, but in the dry grasslands of winter, they blend surprisingly well. For decades, they vanished entirely, surviving only in captivity until careful reintroduction programs restored them to protected reserves. Geneticists now monitor these populations closely to maintain diversity while preserving the rare trait. Their ghostly beauty has become both a blessing and a challenge, an emblem of conservation success and a reminder that rarity alone cannot guarantee survival in the shrinking wild. Ligers and tigans are hybrid offspring of lions and tigers. When a male lion mates with a female tiger, the result is a liger, the largest cat in existence. Reverse the pairing, and you get a tigon, generally smaller, but equally fascinating. These hybrids occur only in captivity. Lions and tigers occupy different habitats in the wild and would never naturally meet. Ligers can exceed 1,000 pounds, combining the size of a tiger with the sociable temperament of a lion. Their stripes are faint, their coats often golden, and unlike most big cats, they seem to enjoy swimming. Tigons, on the other hand, inherit more tiger-like features and a compact build. Because their parent species diverged millions of years ago, these hybrids are often sterile, though rare exceptions exist. They serve as living case studies in genetics, illustrating how inherited traits express and blend, proof that biology sometimes experiments simply because it can. Some cheetahs are king cheetahs with elongated stripes instead of spots. Every so often, nature produces a cheetah unlike any other. one with long, dark stripes running down its back instead of the usual spots. These king cheetahs owe their striking pattern to a rare genetic mutation in the TACPEP gene, which affects coat pattern formation. First described in South Africa in the early 20th century, they were once thought to be a separate species. Later, genetic studies revealed they are simply cheetahs expressing an alternative coat design, much like how tabby cats vary in pattern. The elongated markings may offer camouflage in denser vegetation compared to the spotted version suited for open plains. In captivity, the trait can be inherited predictably, but in the wild, it remains exceedingly rare. Seeing one is a once-in-a-lifetime encounter, a vivid reminder that even in a world of precision and adaptation, evolution still indulges in artistry. Genetic diversity among big cats is shrinking due to habitat loss. Across the world, shrinking habitats and fragmented populations are eroding the genetic diversity of big cats. Inbreeding becomes more common when individuals are isolated by roads, farms, or cities, reducing fertility and resilience against disease. Tigers, lions, and cheetahs have all suffered genetic bottlenecks, moments when their numbers fell so low that most surviving individuals shared nearly identical DNA. Scientists now use genetic sequencing to plan breeding programs that reintroduce diversity, ensuring that rare genes aren't lost forever. The cheetah's genome, for instance, shows alarmingly little variation, a legacy of near extinction at the end of the last ice age. Preserving wide, connected landscapes has become as vital as protecting the animals themselves. Without new genetic exchange, even the strongest cats grow fragile over generations. Their survival depends not just on space, but on the invisible thread of variation that keeps life adaptable. Male lions sometimes form lifelong partnerships with a single brother. Male lions often form coalitions, alliances that can last for life. In some cases, these partnerships involve a single brother or close relative. Together, they defend territories, hunt, and share access to females. These coalitions dramatically increase survival chances, allowing males to hold pride lands far longer than solitary rivals. Field studies in Kenya and Botswana reveal that paired brothers communicate constantly through body language and synchronized roaring, their cooperation so seamless it resembles choreography. The bond isn't merely strategic. When one dies, the survivor often stays near the body for days. Such partnerships highlight the emotional intelligence of lions, social creatures that rely on trust and loyalty as much as muscle and mane. The savanna may seem ruled by power, but its greatest rulers are those who learn to share it. Two brothers walking the grasslands as one enduring force. Some tiger subspecies have vanished entirely within living memory. A century ago, 9 subspecies of tiger roamed across Asia. Today, only 6 remain. The Bali, Yovan, and Caspian tigers disappeared during the 20th century, victims of hunting, deforestation, and human expansion. Each loss erased not only a population, but a unique genetic heritage shaped by geography. The Bali tiger, smallest of all, once inhabited island forests no larger than small counties. The Caspian tiger prowled Central Asia's reed beds and river valleys, its range stretching for thousands of miles. Remarkably, genetic analysis suggests the Caspian and Siberian tigers were nearly identical, meaning reintroduction may someday restore part of what was lost. These extinctions are recent enough that photographs and records remain, haunting reminders that even apex predators can vanish in a human lifetime. Each missing tiger represents a broken branch on an ancient evolutionary tree still struggling to hold its shape. Leopards on islands can evolve to half the mainland size. Island populations of leopards, like many isolated species, often follow the island rule. evolving smaller bodies due to limited prey and confined territory. On Java and Sri Lanka, historical specimens show adults weighing barely half their mainland counterparts. Over generations, natural selection favors individuals requiring fewer resources, leading to compact yet fully functional predators. This process, known as insular dwarfism, appears across multiple animal groups, from elephants to owls. Leopards' adaptability makes them particularly adept at scaling themselves to fit their environment. Genetic analysis suggests these island populations diverged thousands of years ago, forming miniature versions of their ancestors. Despite their size, they remain capable hunters, taking monkeys, birds, and small deer. Evolution's quiet sculpting shows that strength doesn't always mean size. Sometimes survival comes from learning how to be smaller in a world that keeps shrinking. Jaguars in dense rainforests grow smaller than those in open plains. Not all jaguars are the same size. In the dense jungles of the Amazon, jaguars tend to be smaller and more compact than their relatives in open grasslands or wetlands. This variation reflects an evolutionary trade-off, maneuverability over raw strength. Navigating thick vegetation favors agility and stealth, while larger jaguars of the Pantanal, the world's largest wetland, need size and power to tackle capybaras, caimans, and giant anacondas. Studies show that diet, prey availability, and climate all influence jaguar body size across regions. Genetic differences are subtle but measurable, hinting at long-term local adaptation. Despite these variations, all jaguars remain part of one species, a testament to their incredible flexibility. Whether prowling shadowed rainforest or sunlit floodplain, the jaguar adjusts quietly, proving that evolution rewards not just might, but the ability to fit perfectly into the rhythms of place. Snow leopard's thick fur is the densest of any big cat. No animal embodies the word insulation like the snow leopard. Its coat contains up to 12,000 hairs per square inch, the densest of any big cat, and among the thickest in the world. This fur grows up to 5 inches long on the belly, protecting the cat from temperatures that can plunge below 40 degrees below zero. The individual hairs are hollow, trapping air for warmth without adding weight. Under magnification, the texture resembles fine silk rather than coarse hair, explaining its legendary softness. The pale grey color, scattered with smoky rosettes, provides perfect camouflage against snow and stone. When blizzards roll through the Himalayas, snow leopards simply curl their tails around themselves and vanish into the whiteness. Their survival in such extremes shows evolution's artistry, an animal engineered to thrive where even breath seems frozen in place. Lions rule the open grasslands of Africa. The African lion reigns over the continent's sweeping savannas, an ecosystem built on open visibility and coordination. Their social structure suits these vast plains. Cooperative hunting allows prides to target herds that would overwhelm solitary predators. Females fan out across the grass, moving silently until one signals the charge. Males patrol the perimeter, their roars carrying across miles of open air. These behaviors make lions keystone species, maintaining balance among herbivore populations and preventing overgrazing. Without them, ecosystems shift dramatically, grasslands turning to scrub and soil erosion increasing. Their dominance isn't just physical, it's ecological. A healthy pride indicates a healthy savanna. Yet human expansion and conflict are reducing this range each year. Even so, where lions still walk, the land feels alive, an ancient partnership between predator, prey, and plain, each depending on the other's enduring rhythm. Tigers prowl the dense forests of Asia. From India's mangroves to the Siberian taiga, tigers are the undisputed rulers of Asia's forests. Each subspecies has adapted to a different realm. Bengal tigers swim through swamps, Sumatran tigers navigate tangled rainforests, and Amar tigers stalk through snow. Their orange coats blend into the filtered light of leaves and shadow, an illusion of flame flickering between trees. They maintain enormous territories, often spanning dozens of miles, marking them with scratches and scent. In these silent realms, the tiger's presence defines the ecosystem, keeping herbivore numbers balanced and shaping vegetation patterns. Conservationists call them umbrella species because protecting them safeguards countless others beneath that canopy of protection. When a forest falls silent except for one low rumble of breath, that's the tiger, the embodiment of Asia's remaining wild heart. Their survival ensures the forest itself continues to breathe. Jaguars move silently through rainforests and swamps. In the tropical wetlands and jungles of the Americas, jaguars move like ghosts. Their broad paws muffle every step, spreading weight over soft ground. Unlike most cats, they're comfortable in water, gliding through flooded forests to ambush prey. Their spots mimic the shifting pattern of sunlight through leaves, dissolving their form into shadow. Jaguars are apex predators, controlling populations of deer, capybaras, and reptiles. Even crocodilian caimans fall to their crushing bite. Ecologists studying their movements found that jaguars prefer pathways along river systems, where they can both hunt and cool themselves. They rarely roar, instead, they grunt or cough to communicate across short distances. Each movement feels deliberate, an echo of ancient patience. Where jaguars still roam, the jungle stays balanced, a living testament to how silence can be the most powerful sound in nature. Leopards adapt to nearly every environment on Earth. Among all big cats, the leopard may be the most adaptable. They live in deserts, rainforests, savannas, and even on the outskirts of major cities. Their flexibility comes from a broad diet. They can hunt anything from insects to antelope, and from their stealthy, solitary nature. Leopards climb trees to avoid scavengers, rest in caves during extreme heat, and adjust hunting hours to avoid humans. Their ability to thrive in such diverse habitats has made them the most widespread big cat species, stretching across Africa and Asia. In urban India, some even survive near bustling suburbs, slipping through alleyways at night and returning to forested edges by dawn. This adaptability hides a quiet truth. Leopards are survivors of change. Where other species falter, they adjust, a living blueprint of resilience in a rapidly transforming planet. Snow leopards thrive at altitudes higher than most birds of prey. No other big cat lives as high as the snow leopard. These elusive predators inhabit mountain ranges reaching over 18,000 feet above sea level, elevations where even eagles struggle to soar. The air there holds less than half the oxygen found at sea level, yet snow leopards move effortlessly, supported by deep chests, large nasal passages, and blood rich in oxygen binding hemoglobin. Their territory spans cliffs, glaciers, and scree fields, landscapes so barren that prey is scarce. To survive, they roam vast areas, following herds of blue sheep and ibex across seasons. Scientists tracking them with satellite collars have recorded journeys spanning more than 100 miles in just a few weeks. They are, in every sense, mountain phantoms, creatures that have turned the thin air of Earth's roof into a kingdom few others can endure. Cheetahs prefer open plains where their speed can unfold. Cheetahs thrive in landscapes that match their greatest asset, open space. The wide grasslands and light woodlands of Africa offer room to accelerate, to reach the staggering speeds their bodies were built for. Prey species like gazelles and impalas also favor open terrain, creating a natural arena for the chase. In these vast spaces, cover is minimal, so cheetahs rely on stealth until the final burst. Their tan coats speckled with black spots blend seamlessly with waving grass, masking their approach. Once in motion, the chase becomes a breathtaking display of balance and agility. Predator and prey, locked in a fleeting dance of survival. But this specialization makes them vulnerable when open land gives way to farms or roads. Their domain shrinks. To see a cheetah sprint across a plain is to glimpse perfection in motion, an animal designed for pure, fleeting grace. Cougars survive in deserts, forests, and mountains alike. No big cat spans more habitats than the cougar. From the frozen peaks of Canada to the deserts of Patagonia, these solitary hunters have mastered nearly every landscape in the Americas. Their secret is adaptability. Cougars adjust diet, hunting techniques, and territory size to match their environment, stalking deer in forests, ambushing guanacos in high plains, and subsisting on hares in deserts. Their range once stretched across both continents uninterrupted, and even today, they're returning to regions long thought empty of large predators. In the United States, cougars have recolonized parts of the Midwest, proving how resilient wildlife can be when given space. Unlike lions or tigers, they require no pack or pride, just silence and patience. The cougar endures not through dominance, but through quiet versatility, reminding us that survival often favors those who move lightly across the map. Big cats shape the ecosystems they inhabit, keeping prey populations balanced. Every big cat acts as a keystone species, maintaining equilibrium within its ecosystem. By preying on the old, weak, or overabundant animals, they regulate populations and prevent habitat degradation. In Africa, lions keep herbivores from overgrazing fragile grasslands. In Asia, tigers control deer and boar numbers, allowing forests to regenerate. When predators vanish, prey multiply unchecked, vegetation declines, and smaller species suffer, a cascade of imbalance known as trophic collapse. Ecologists have documented entire landscapes recovering after big cats were reintroduced. Rivers changed course, trees regrew, and biodiversity flourished. Their influence extends far beyond what they eat. It reshapes the land itself. Every roar, every hunt, echoes through the food chain. The health of the forest or savanna often begins with the predator's shadow, proof that balance depends on the silent guardians at the top. When big cats vanish, entire landscapes begin to unravel. The disappearance of big cats triggers changes that ripple through entire ecosystems. When tigers were eradicated from parts of Asia, deer populations exploded, stripping forests bare. Where lions declined in Africa, hyenas and baboons expanded, altering predator-prey dynamics and increasing human-wildlife conflict. This phenomenon, known as a trophic cascade, reveals how tightly life is interconnected. Without apex predators, balance collapses, and even plants and rivers respond to the void. Scientists studying rewilding projects in India and Africa have seen how returning just a few big cats begins to reverse the damage. Vegetation recovers, water cycles stabilize, and prey regain natural behaviors. It's as though the land itself breathes differently in their presence. Their loss is not merely the absence of beauty or power, it is the unraveling of structure, the silence left when an entire symphony loses its leading note. Their presence signals the health of an entire biome. Ecologists often call big cats indicator species. Their continued presence suggests that the ecosystem beneath them, prey, vegetation, and climate, remains intact. A thriving tiger population means healthy forests and abundant herbivores. Lions on the plains signal balanced herds and open habitats. Because they require large territories, protecting big cats indirectly preserves countless smaller species within the same web. Conservationists use their population trends like a heartbeat reading of the wild. When those numbers drop, it warns that something deeper is wrong: deforestation, poaching, or climate disruption. Saving one apex predator often saves entire landscapes. In this way, big cats serve as both symbols and systems, living proof that balance endures only when all its parts remain connected. Where the roar continues, life still finds its rhythm. Fewer than 4,000 wild tigers remain today. Across Asia, the sound of a tiger's roar has grown heartbreakingly rare. Once ranging from Turkey to the Pacific, tigers now survive in fragmented pockets scattered across 13 countries. Global estimates suggest fewer than 4,000 individuals remain in the wild, fewer than the number of tigers once held in captivity worldwide. Their decline stems from deforestation, poaching, and the illegal wildlife trade. Yet there is hope. India's Project Tiger, launched in the 1970s, has helped double populations in some reserves. In Nepal and Bhutan, coordinated patrols and community-led conservation are reversing decades of loss. Every surviving tiger represents a triumph of patience, protection, and persistence. In the quiet forests where they still walk, camera traps occasionally flash, a spite-second image proving that the fire-striped hunter has not yet gone out. It is the faint heartbeat of wilderness itself, refusing to be silenced. Lion numbers have fallen by nearly half in the last few decades. In just 50 years, Africa's lion population has dropped by almost half. Once roaming across the continent and into the Middle East, lions now occupy less than 10% of their historical range. Habitat loss, human conflict, and poaching have all taken their toll. Yet despite this decline, some populations are rebounding thanks to cross-border conservation projects like the Kavango Zambezi Transfrontier Park, an immense protected corridor allowing prides to move safely between countries. Technology helps too. Satellite collars reveal migration routes, while local communities use early warning systems to prevent livestock attacks. Conservationists stress that coexistence is the key, ensuring people and predators share the same landscapes without competition. Each pride that survives carries the ancient rhythm of the savanna forward, reminding us that saving lions isn't about preserving symbols of power, it's about maintaining the heartbeat of Africa itself. Habitat corridors are being built to reconnect isolated populations. As human development fragments the wilderness, many big cats find themselves trapped in shrinking islands of habitat. Without movement between them, inbreeding and starvation threaten even stable populations. To counter this, conservationists are creating wildlife corridors, stretches of protected land or elevated crossings that link separated ecosystems. In India, corridors between tiger reserves now allow safe passage for breeding adults. In Kenya, similar networks help lions and leopards cross between parks without encountering farms or roads. Even in North America, underpasses and overpasses are helping cougars reclaim ancient routes through the Rocky Mountains. These corridors act like veins through which the wild can breathe again, reconnecting the genetic flow that sustains life. When scientists track the first animal to safely cross a new bridge, it's more than a data point, it's a moment of reconnection between broken worlds. Camera traps reveal new individuals once thought extinct. Hidden deep in forests, motion-triggered cameras are rewriting what we thought we knew about extinction. These silent sentinels have captured images of big cats long believed to have vanished, from Indo-Chinese leopards in Cambodia to tigers in regions once declared empty. Each photo arrives like a pulse from the unseen world, an eye glinting in infrared light, a faint stripe pattern confirming identity. Scientists use software to match these markings against databases, revealing individual lives unfolding far from human view. Entire populations have been rediscovered this way, sparking urgent conservation efforts before it's too late. The technology proves a profound truth. Absence of evidence is not evidence of absence. Even in a world mapped and measured, the wild still holds secrets. Every blurred image of a hidden predator is a reminder that mystery still moves quietly through the leaves. Anti-poaching units now use drones and AI tracking. Modern conservation has become a high-tech pursuit. In protected reserves across Africa and Asia, anti-poaching teams use drones equipped with thermal cameras to patrol vast landscapes from above. Artificial intelligence analyzes footage in real time, identifying human movement or vehicle patterns that might indicate illegal activity. These digital guardians can cover terrain that would take rangers hours to traverse. Combined with on-the-ground patrols and sniffer dogs trained to detect animal products, these tools have dramatically reduced poaching incidents in several hotspots. In India, AI-assisted networks monitor tiger reserves 24 hours a day, while in Kenya, predictive models map potential poaching routes before they happen. It's a quiet technological revolution, machines working not for exploitation, but for protection. When drones hum softly over moonlit savannas, they're not intruding on the wild, they're helping to keep its silence intact. Genetic studies help prevent inbreeding in captive populations. In zoos and breeding centers worldwide, scientists carefully manage the genetics of captive big cats to preserve healthy diversity. DNA analysis identifies which individuals should mate, avoiding inbreeding that can cause health defects. This practice, known as genetic pairing, is guided by vast databases tracking lineage and ancestry. For endangered subspecies like the Amur leopard or Sumatran tiger, these programs act as lifelines, insurance populations should wild numbers ever collapse. Advances in genome sequencing now allow researchers to monitor even tiny mutations and immune system markers. Some facilities exchange animals internationally to keep gene pools broad and resilient. Though captivity can never replace true wilderness, it serves as a biological vault, preserving the blueprint of life. Every cub born under these conditions is not just a captive creature. It's a carefully protected chapter in evolution's long, fragile story. Ecotourism can protect big cats by giving them economic value. In regions where poverty and wildlife collide, ecotourism has become one of the most effective conservation tools. When tourists pay to see lions, tigers, or leopards in their natural habitats, the revenue flows directly into local economies, funding rangers, schools, and jobs. This shifts community incentives. A living lion is now worth far more than a hunted one. Countries like Botswana, Namibia, and India have demonstrated how well-managed tourism can transform predators from perceived threats into valuable assets. But it must be done responsibly. Too much disturbance can harm the very species it aims to protect. The best programs cap visitor numbers, train local guides, and ensure that profits stay within nearby villages. Done right, ecotourism turns admiration into protection, weaving human livelihood and wildlife survival into the same sustainable thread. Rewilding projects aim to return predators to their lost territories. Rewilding is the practice of restoring ecosystems by reintroducing key species, and big cats are often at the center of it. In Kazakhstan, scientists are working to re-establish Caspian tigers using close relatives from Siberia. In South Africa, lions and cheetahs have been reintroduced to regions where they vanished a century ago. These efforts require years of preparation, restoring prey populations, building corridors, and engaging local communities. The results can be spectacular. In India's Panna Tiger Reserve, tigers returned after complete local extinction, and within a decade, the forest's vegetation and rivers revived. Rewilding doesn't just restore species, it rebuilds relationships between land, animal, and time. It's a reminder that loss isn't always permanent, that with care, patience, and cooperation, even the wild can heal itself when we step back and give it room to breathe again. Every roar recorded and mapped helps scientists track individuals. The sound of a big cat's roar carries information as unique as a fingerprint. Each roar contains subtle variations in frequency, duration, and pitch that identify individuals. Scientists now use remote acoustic sensors to record these sounds and map the presence of specific lions or tigers across large territories. Software analyzes thousands of hours of recordings, building sound maps of populations without disturbing them. In the future, this method may replace invasive tagging entirely. It's also helping monitor rewilding programs and measure the return of species to former habitats. The concept is elegant, using sound, their own natural language, to understand and protect them. Each roar captured and catalogued is more than data, it's proof of life echoing across the landscape, a sonic heartbeat of the wilderness, reminding us that even silence carries memory. Big cats may be the ambassadors that reconnect humanity with the wild. Few animals capture human imagination like big cats. Their strength, beauty, and mystery bridge the gap between fear and fascination, the same emotions that once kept our ancestors alert beside the fire. Today, as wild spaces shrink, these cats stand at the frontier between civilization and nature. Protecting them means protecting entire ecosystems, and, by extension, our own survival. They've become ambassadors for the natural world, embodying the idea that awe can inspire stewardship. When people see a tiger in the wild or hear a lion's roar at dusk, something ancient stirs, a recognition that we're part of the same world, not apart from it. Their future is bound to ours. To save them is to save a fragment of our shared history, a reminder that wonder itself might be the most powerful conservation tool we possess. Even their fossils have shaped our understanding of evolution. Fossilized remains of ancient big cats have rewritten evolutionary history again and again. From saber-toothed Smilodon in the Americas to Panthera spelaea, the European cave lion, these bones reveal how adaptable the feline family truly is. By studying wear patterns on teeth and isotopes in bone, scientists reconstruct entire food webs from tens of thousands of years ago. DNA extracted from fossils shows unexpected relationships, for instance, that the modern lion is closely related to extinct Ice Age species that once roamed Alaska. Each fossil is a time capsule, a record of climates, prey, and migration routes. They show that big cats have survived ice ages, droughts, and continental shifts, adapting endlessly. The fossils whisper a quiet message. Change is inevitable, but persistence can span epochs. Evolution isn't just progress, it's endurance written in bone. Ancient DNA reveals migrations that mirror human history. As scientists sequence ancient DNA from fossilized cats, remarkable parallels emerge between their movements and ours. Lions once spread across Africa, Europe, and Asia, following the same migration corridors early humans later traveled. During the Ice Age, lions crossed land bridges into North America, just as people did. These overlapping timelines suggest that our species and theirs have shared landscapes and conflicts for over 100,000 years. Genetic studies show how isolation shaped regional adaptations. Cave lions grew larger in cold climates, while tigers diversified across Asia's forests. Tracing these migrations isn't just about cats. It's about understanding how ecosystems evolve alongside humanity. We were never alone on our journey. We've always walked in parallel with other apex species, watching each other, shaping each other's destinies across time's wide horizon. Big cats once roamed Europe, even as far north as Britain. During the last ice age, Europe was home to true lions. Anthera spelea, the cave lion, prowled from Spain to Siberia, hunting reindeer, horses, and bison. Fossils found in England and Germany prove that even the cold north was once its domain. Standing larger than modern lions, it bore faint striping and a shorter mane. Cave paintings in France's Chauvet Cave depict these lions with remarkable accuracy, some shown without manes, suggesting female hunters or perhaps different social roles. The extinction of cave lions around 13,000 years ago coincides with climate change and human expansion. Their disappearance transformed Europe's ecosystems, leaving behind silence where thunder once echoed. Yet in art, they remain, painted in ochre and charcoal, testaments to a time when lions walked under northern stars and humankind was young. Cave paintings show that early humans feared and revered them. Some of the earliest art ever made features big cats. In France's Chauvet Cave, 20,000-year-old paintings depict lions hunting bison, drawn with astonishing precision. These weren't decorations, they were expressions of awe and understanding. Archaeologists believe such images reflected both reverence and fear, humans recognizing a rival predator, yet admiring its grace. Across continents, similar depictions appear, from leopards in African rock art to tigers carved on ancient Chinese bones. These portrayals show that our relationship with big cats predates language itself. They were the first animals to inspire us to draw, to mythologize, to tell stories. Each brushstroke and carving carries the same unspoken message. We saw something magnificent and wanted to remember it. Art, in a way, began as humanity's first form of conservation, an attempt to keep what we feared might one day vanish. Their bones have been found beside ancient human shelters. Archaeological sites across Europe and Asia have uncovered bones of lions, leopards, and even tigers near prehistoric human settlements. Some were likely hunted for fur or meat. Others appear to have been ritual offerings. In certain caves, lion remains rest beside human burials, suggesting spiritual connection rather than conflict. Scientists studying cut marks on these bones reveal how early humans viewed predators both as danger and resource. These finds blur the line between hunter and hunted, evidence that our ancestors lived within the same ecological web, not apart from it. The proximity of these remains reminds us that coexistence with large carnivores isn't new. It's an ancient negotiation stretching back tens of thousands of years, a conversation between species written in fossilized silence, now rediscovered bone by bone. Some Ice Age humans wore necklaces made of cat teeth. Across Ice Age Europe, archaeologists have uncovered necklaces fashioned from the teeth and claws of lions and leopards. Each piece was painstakingly drilled or grooved to be strung on sinew or fiber. These ornaments may have symbolized courage, status, or spiritual power, the wearer borrowing the essence of the predator. In some burials, children were interred with such necklaces, perhaps as protection in the afterlife. These objects blur the boundary between tool and talisman, art and identity. To hold one today is to feel a pulse of continuity, humans reaching for meaning through the symbols of the wild. The instinct to honor the predator by wearing a part of it may seem primitive, yet it reflects something timeless, an awareness that strength, beauty, and survival are threads in the same fabric. The lion's tooth around a neck was not just adornment, it was respect made visible. The word cat itself has ancient roots shared across languages. Linguists trace the word cat back thousands of years through a web of connected tongues. The Latin catus became chat in French, gato in Spanish, and cat in Old Norse. All stem from an earlier Afro-Asiatic root, likely Egyptian, reflecting how the first domesticated cats spread alongside human trade and culture. Ancient Egyptians revered felines so deeply that their word court may have inspired the terms migration across continents. The linguistic journey mirrors our fascination with all cats, large and small. Even the mighty panthera, used in scientific classification, carries echoes of Greek mythology, meaning all beasts. Words like species evolve and travel. That the name for these animals has survived nearly unchanged across millennia speaks to their enduring place in human thought, ever familiar, ever untamed, bound to us by sound as much as by history. The future of big cats depends on global cooperation. No single nation can save big cats alone. Their ranges cross borders, their threats span continents, and their fate is intertwined with climate, trade, and human expansion. Conservation today relies on international alliances, data-sharing networks, cross-border patrols, and collaborative legislation against wildlife trafficking. Programs like the Global Tiger Forum and Panthera Foundation coordinate scientists and policymakers across dozens of countries. Even satellite imagery now helps track deforestation that affects habitats thousands of miles away. Cooperation between governments, local communities, and NGOs has already revived populations once thought doomed. The lesson is clear. Big cats do not recognize borders, and neither can their protection. Saving them requires thinking at the scale of the planet itself, a shared responsibility stretching from village edge to policy table, guided by one common understanding, that the raw belongs to everyone. Every conservation success begins with awareness. Conservation begins not in forests or plains, but in understanding. In the moment someone learns that their curiosity can help something wild survive. Awareness fuels action, supporting sanctuaries, reducing demand for animal products, or simply spreading truth instead of myth. Modern campaigns use social media and virtual experiences to connect people with species they may never see in person. A single shared image of a rescued cub or rewilded tiger can spark donations that sustain entire programs. Scientists often say that saving big cats requires both biology and storytelling, the data and the dream. When people care, ecosystems heal faster. Awareness is contagious in the best possible way. The first step toward protecting the raw begins with listening, hearing it, valuing it, and passing it on so that others too may remember what wilderness sounds like. Their story is ultimately our own, a shared history of survival. For hundreds of thousands of years, humanity and big cats have lived side by side, rivals, companions, teachers. We feared them, painted them, hunted them, and eventually began to protect them. In their evolution, we glimpse our own adaptability, intelligence, resilience. We both rose from fragile beginnings to shape our worlds, each in our own way. Now, as wilderness dwindles, our fates are intertwined again. Whether they continue to roam free depends on whether we can coexist rather than conquer. To protect them is to protect a mirror of ourselves, the part that still remembers the pulse of the wild, the silence of the hunt, the awe of golden eyes meeting ours in twilight. Their survival is not just about saving animals. It's about preserving the ancient dialogue between humanity and nature, a conversation still worth continuing. And so, our quiet journey draws to a close. From the gold-lit savannas of Africa to the silent ridges of the Himalayas, We've followed paw prints through forests, across deserts, and into time itself. Everywhere they've walked, big cats have left echoes, not just in the soil, but in us. These animals are more than predators. They're architects of balance, shaping the rhythm of every landscape they touch. When a lion roars, it's the sound of the grasslands remembering who they belong to. When a snow leopard slips between clouds, it's the mountain breathing in silence. And when a tiger moves through the forest, even the wind seems to hold its breath. Their survival depends on us now, on how gently we tread, how carefully we listen. To save them is to protect something deep and wordless in ourselves, that ancient awareness of wildness, of life lived uncontained. Perhaps that's why we find peace in their presence. There's a kind of stillness in watching strength tempered by grace, a reminder that power doesn't always roar. Sometimes it moves quietly, leaving only the whisper of fur against wind. So, as the night settles around you, imagine the world they still inhabit, the pulse of the savanna under starlight, the hush of a jungle before dawn, the frost-blue breath of a mountain cat in the high air. Somewhere out there, those eyes still shine. The world is still alive with motion and mystery. If you enjoy these quiet journeys, I invite you to like, subscribe, or share a thought below. It helps others find their way here too, one sleepy soul at a time. For now, just breathe. Let your thoughts wander like silent tracks through tall grass. Let your heart beat slow to the rhythm of distant paws. And let the wild carry you gently into dreams, calm, untamed, and free. Good night.